All right, section 5 of chapter 2 is scheduled for today. Section 5, how can I say this? Section 5 is probably the longest section in chapter 2. It is just filled with information on how you can graph by just noting certain characteristics of a function. The interesting thing about this section is it's the one part of chapter 2 that makes it so incredibly easy. Once you see these examples, you're going to find these problems to be amazing. You can look at the equation of a function, and if you know just a few basic facts, you can graph it instantly. So it's, in a way, it's kind of fun. Everybody always seems to do really, really well on section 5. So let's get started. What we're going to talk today is about shifting parabolas, absolute values around, and talking about what their equations are and how that shifts. First, we're going to do our vertical shifts up and down. Having trouble talking today, pardon me. The blue one is f of x, or y equals x squared. The red one is x squared plus 3. The plus 3 just simply moves it up 3. Every y value goes up 3. Okay, that's all there is to it. So if you see a plus 3 on the end of a parabola, on the end of an x squared, you know it simply goes up 3. If you saw a minus 5 would pull it down 5. Still centered on the y-axis, but it'd be down 5. Now, let's talk about the absolute value function. Here, the black one is a basic y equals absolute value of x. The purple one is down 1. So it would be simply y equals the absolute value of x, and at the end, minus 1. Take the 1 off of the whole thing. How about the yellow one? Here's y equals absolute value of x. The yellow one, and I need a marker. The yellow one would have to be y equals the absolute value of x, and it's up 2. Okay? That's all there is to this. Vertical shifts. You've got to add or subtract onto the basic function. Here's square roots. The black one in here is basically y equals square root of x. Do you see how the red one is up 2? So the red one, all right, y sub r for red one would be square root of x plus 2. The green one would be y sub g square root of x minus 2. Okay? I'm not making this up. It's that easy. How about the cubic? The red one is the basic cubic. This might be a little tricky to see. The red one is the basic cubic. It looks like the very bottom purple one right here goes through negative 3. It's down 3. So that purple one, y sub purple, would simply be x cubed minus 3. Okay? Those are called vertical shifts. Now, why does that do that? All right. How about horizontal shifts? If it was all just as easy as this, but the horizontal shifts are a little tricky. All right. Right here, we have an absolute value, the pointy graph. Now, you know a basic absolute value hits at the origin. Okay? This one, you maybe can't see this, but it's over 3 units. All right? To the right, which you're saying, positive 3, positive 3. Not exactly. If you have y equals absolute value of x, would be right here in the middle. If you want to get it to turn around at 3, you want the y value to be 0. Okay? What can you do here to make this y value at 3 be 0? You're going to have to do that. Okay? 3 minus 3 would be 0, and the absolute value is 0. Put 4 in. 4 minus 3 is 1. Absolute value is up 1. Okay? Here's the interesting thing about horizontal shifts. If you want to push it over 3 to the right, you've got to put the opposite, a minus 3, and it has to go in with the x. You don't just put a minus 3 on the end. A minus 3 on the end is going to pull it down 3. Correct? So here, this blue one is 4 units to the left. Okay? It started out as this, right? If you want to go 4 units to the left, you can't do a minus 4. You want this y value to be 0, so it's got to be a plus 4. Now, when you put negative 4 in there, you do get 0. Okay? So a negative sign moves it to the right, a positive sign moves it to the left, but it's got to be in with the x value. Are you with me? Here's square roots. Let's talk about this one. The black one would be just your basic y equals square root of x. The brown one is 2 units to the left. So that one should be square root, because we're going to the left, it should be x plus 2. Okay, check it. Negative 2, right where it bottoms out at 0. Negative 2 plus 2, 0. Square root's 0. Checks beautifully. Over here, the blue one is y equals x squared, your basic parabola. If you want to move that parabola 2 units to the right, you got to have it be a negative 2. Okay? Vertical shifts, you add, it goes up, you subtract, it goes down, and you add it to the whole function. Horizontal shifts, you do the opposite. If you want to go to the right, use a negative. You want to go to the left, use a positive. And it must be with the x value. Now, what about a combination of the two? Vertical shifts and horizontal shifts. Combination of the two. The blue one is your cubic, y equals x cubed. Let's talk about it. Look what we've done. We've gone over 2 and up 3 to the red one. See it? Over 2 and up 3. The over 2 is a horizontal shift. So it's got to be an x minus 2. The opposite, huh? 2 to the right is a minus 2. Then up 3 is just a plus 3. This is incredibly easy. How about this square root? Okay? We go 1 to the right, and then we go up 2. So we know it's a square root. If you want to go 1 to the right, is it not minus 1 in with the x? And then to push it up 2, you would add 2 to the whole thing. Check a point, for crying out loud. Put a 1 in. 1 minus 1 is 0. Square root of 0 is 0 plus 2, 2. Boom. Okay? Look at this parabola. This parabola is moved over 3 to the right. See the minus 3? Okay? It's then taken down 4. Moved down 4. And the 1/2 makes it a little bit wider. We talked about this, I think it was the last time we were together. We're going to talk about it some more together, or today. 1/2 would make it wider. Whole numbers would make it more narrow. Okay, reflections can be a little tricky. So, let's talk about a reflection. Here, this blue one is the square root of x. Okay? If you put a negative sign in with the x, the opposite of all these negative values is positive, and then you can take the square root and it's going to look like this. A negative sign in with the x flips it to the left and right. Okay? If you put the negative sign in front of the square root, here's your square root function. If you put it in front, all of these values become negative and they go down here. So let's summarize that. If you put a negative sign in with just the x, it flips it left and right. But if you put it in front of the function, it flips it up and down. Okay? Those are reflections. It works for parabolas. How about parabolas? If I take y equals x squared and put a negative sign in front, it's going to make all these positive values negative. They're going to say the same value, like 3 goes to 9. But put a negative sign in front, it's going to become negative 9. And of course, 0 stays 0. Negative sign in front of the whole thing flips it up and down. Now, what if you were to take y equals x squared, the blue parabola, and if you were to put the negative sign in with just the x? If you were to put a negative sign in with the x, well, we just talked about that. With the x is going to flip it left and right. Flip it left and right, it's going to look precisely like this. That's weird. It's going to look precisely like that. And yes, because a negative squared is a positive, it's exactly the same thing. Pretty cool. We know our basic absolute value function hits at 0. Plus 1 moves it up. Now, if you take a negative and hit the whole function, negative and hit the whole function, okay, it becomes this. Negative absolute value and a minus 1, it's going to flip it down. Instead of being up 1, it's going to be down 1, and it's going to be opening down. Okay? Let's take this absolute x plus 1 again. Absolute x plus 1 is this red one. It's up 1. How about if I put the negative sign in with the x? If I put the negative in there? Well, the absolute value of the negative in there, it should flip it right and left. Doesn't it? When you flip it right and left, doesn't it stay the same thing? And isn't the absolute value of a negative the same as the absolute value of a positive? Right? So it stays the same. These are so easy. Now, a little bit more on the fractions and whole numbers. The blue one is your basic parabola. Okay? The green one has a 4 in front of the x squared. That's going to make it go up much more sharply. Okay, the author likes to call that shrinking. I just say it gets narrow and goes up more quickly, pardon me. If you put a fraction in front of the x squared, like a 1/4, each value of the blue is going to be divided by 4. So it's going to make it really widen out, stretched apart, okay? Or as the author would say, it shrinks. But it's much wider. I think that's easier. Narrow and wider. So, can we sketch? All right, I'm going to try to go through these. Hopefully, you're going to see how incredibly easy these are. All right, so here we go. Here we have a parabola. We know it's an x squared. Plus 3 moves it up 3. Yes? A negative sign flips it. Flips it. Okay, so it's going to have to go down. Okay, open down. And a 1/2 makes it wider. So it should look like, make it much wider, and it opens down. Okay? How about this one? Still an x squared. Still a parabola. Okay? Maybe I can get it on here. A -2 with the x, if you remember, a -2 with the x moves it to the right 2. So instead of turning around here, it's going to go to the right 2. Then it's going to go down 3. And here, it's still going to open up, but the value of 2 makes it super narrow. And you don't have to be fussy about this. You don't have to plot any points, make it super wide, make it super narrow, just so I can tell you know what you're talking about. All right, that last one is kind of a tricky one. The first thing I do is take 4 minus 3 and get 1. All right? So 4 minus 3 is 1. A positive 1 moves it up 1. Okay, so we're going to go up 1. But this plus 2 here with the x, the plus 2 with the x, does it not move it to the left 2? So it's to the left 2 and up 1. Okay, let's do that again. 4 minus 3 was 1, up 1. Positive 2 with the x, 2 to the left, and then up 1. 1/2 makes it super wide. Negative sign flips it upside down. There it is. Okay? One more. Absolute value, x minus 2 plus 3. The minus 2 with the x moves the absolute value over here. The plus 3 moves it up 3, and then it's just your absolute value. All right? Okay. May come back and do some more of these. All right, let's talk about odd and even functions. A function is odd if the functional value of a negative is the opposite of the functional value of the positive. All right? So here's a classic odd function. If you can see this, can you all see that? It's kind of small. My apologies, but I think you can see it. Suppose this is a cubic. Y equals x cubed. 2 would go to 8. Where does negative 2 go? If negative 2 goes to the opposite, to negative 8, it's an odd function. So this cubic is an odd function, okay? A function is odd when it's symmetrical to the origin. You see how that bounces up and down diagonally with the origin, okay? A function is even if f of x is the same as the functional value of the negative. For instance, here's a parabola. Here's a parabola. We know 2 goes to 4, 2 squared. 2 goes to 4, and negative 2 also goes to 4. Goes to the same place. Y equals x squared is an even function. It is symmetrical to the y-axis. Okay? Let's go back. This one is symmetrical to the origin. Okay, so this would be an odd function. Absolute value function is symmetrical to the y-axis. That's an even function. Wow, look at this guy. Looks like a sine curve. Do you see how we're symmetrical to the origin? This is an odd one. Symmetrical to the origin, that's an odd one. Symmetrical to the y-axis, it's the same mirror image, that's an even. Symmetrical mirror image to the y-axis, so that one is also an even one. Now, what if you don't have a graph? What if you don't have a picture, like y equals x to the 5th? Okay? Try value. Just put in 2. Okay, when x is 2, this is 32. Now put in negative 2. Negative 2 to the 5th is negative 32. It's the opposite of the positive value. It's 32 and negative 32. It's an odd function. Okay? Will it always be odd if it's an odd power? Yes. If there's nothing else involved. If it's just an x to an odd power, yeah. What about this one? You might guess it's going to be even. Let's try it. Put a number in. Put 2 in. 2 would be 2 to the 4th is 16. That's going to give me 0. Pick something different. Put 3 in. 81 minus 36 is 45, I think, 45. Now put in -3. 81 minus 36 is 45. Same value, that's an even function. Let's try this one. Let's try 2 and -2 again. If you put 2 in here, 2 plus a half is 2.5. Put -2 in, -2 plus a -1/2 is -2.5. That's an odd one. Okay, odd and even functions. Big deal in calculus. More on sketching. All right, let's do some more sketching. I told you this was an easy section. All right, square root. We know the basic square root looks like that. Of +3 with the x moves it to the left, the opposite. So we're going to come back 3, and a -5 on the whole thing sucks it down 5. So we're here, and it still looks like that. Okay? Absolute value. We know what an absolute value looks like. I'll do it in a dotted line. Here's an absolute value. The 1/2 makes it wide. The -3 down 3, and it's much wider. Okay? Let's do it another one. Cubic. You know what a cubic looks like? A cubic, basic cubic. Now, a -2 with the x should move it to the right. 2 over here. And it would still look like a cubic. But a 2 is going to make it go up much more quickly. It becomes narrow. The minus sign on the whole function flips it up and down. So instead of having a cubic go this way, it flips it up and down. And the cubic is going to be much more narrow and come down like that. Are you with me? Okay, parabola, right? Stays at the origin, 1/2 makes it very wide, negative, upside down. That's all there is to this. Square root. Square root looks like this. Negative with the x flips it left and right. Okay? Square root looks like this. +7 to the whole function moves it up 7. It's up here, and it still looks exactly the same. Okay? These are called shifts of functions, and they are a lot of fun. If you get so excited, get back to me, and I can even give you some more of them if you like. They are just a tremendous amount of fun. So good luck. You shouldn't have much trouble with the homework at all.